everyone, today I will be teaching you how to factor polynomials using factor theorem. How do we identify if that polynomial is a factor to the other polynomial? To give you a quick review, when you were in your lower years, when we are going to get factors of a number like here 10, we all know that factors of 10 are 2 and 5. Because when you multiply 2 and 5, that is equal to 10, right? So by dividing 10 also by one of these numbers, let us say for example 5, 10 divided by 5, that is 2. 2 times 5, that is 10. Minus, here the remainder is equal to 0. Hence, we can say that if we're going to divide one of the factors by, which is 5 by 10, it will give you a remainder of 0. So we can conclude that once it is a factor, the remainder should be equal to 0. Likewise, in polynomials, when we are going to identify if it is a factor or not, we will just have to divide the two polynomials and the remainder should be equal to 0. So we can say that that polynomial is a factor to that other polynomial. Let us see, for instance, number 1. If we're going to let's identify if d of x is a factor of p of x, or x plus 2 a factor of x to the power 4 plus 10x cubed plus 21x squared plus 6x minus 8. So you can use any of the methods that I've discussed to you last week, whether it is synthetic division or long division method. Using synthetic division, we are going to use the numerical coefficient, but check first if the exponents are in descending order of power, so 4, 3, 2, 1, 0. So it is already arranged. So we are going to get the numerical coefficient, which is 1. Next is 10. Next is 21. Next is 6. Next is negative 8. And then what should be the number to be written here? So that comes from d of x, which is x plus 2 equals 0. So x equals negative 2. So here is negative 2. So following the steps in solving polynomials using synthetic division, so we have to bring down 1, then multiply 1 to negative 2, that is negative 2. 10 plus negative 2, that is 8. 8 times negative 2, that is negative 16. 21 plus negative 16, that is 5. 5 times negative 10, that is 5 times negative 2 rather, that is negative 10. 6 plus negative 10, that is negative 4. Negative 4 times negative 2, that is positive 8. Negative 8 plus 8, that is 0. Here is the remainder, which is 0. So we can say that x plus 2 is a factor of x to the power 4 plus 10x cubed plus 21x squared plus 6x minus 8, because the remainder is 0. How about here, example number 2? Let's try to identify if d of a is a factor of p of a. The same procedure, let's use synthetic division. We're going to get the numerical coefficient of this one. So we have 1, 3, 2, 8. Then here is a plus 3, that is 0. So a is equal to negative 3. So negative 3 here. Bring down 1. 1 times negative 3, that is positive negative 3. 3 plus negative 3, that is 0. 0 times negative 3, that is 0. 2 plus 0, that is 2. 2 times negative 3, that is negative 6. 8 plus negative 6, that is positive 2. Here, 2 is the remainder. Since the remainder is not 0, a plus 3 is not a factor of this polynomial a cubed plus 3a squared plus 2a plus 8. Okay, there is also another theorem, that is remainder theorem. This will help you to find the remainder of the polynomial when you divide two polynomials. Now, how do we use remainder theorem? Okay, so we have here, let's try to get the remainder when p of x is divided by d of x. So how do we use remainder theorem then? So we are going to get first the value of x of the d of x. So here we're going to have x plus 2 here, which is equal to 0, so x equals negative 2. Now this negative 2 will be the value of x to be substituted here. P of x here, the p of x equals x to the power 4 plus 10x cubed plus 21x squared plus 6x minus 8. So x here will be substituted by the value of negative 2 here, comes from your d of x. So p x here is negative 2, right? So substitute x, which is negative 2 to the power 4 plus 10 times x is negative 2 to the power 3, copy, plus 21 times x is negative 2 squared plus 6 times negative 2 minus 8. So p of negative 2 is equal to, what is negative 2 times negative 2 times negative 2 times negative 2? That is positive 16 plus 10 to the power negative 2 times negative 2 times negative 2, or negative 2 cubed, that is negative 8, plus 21 times negative 2 times negative 2, that is positive 4. Then you can multiply 6 times negative 2, that is negative 12, or minus 12, copy, minus 8. So p of negative 2 is equal to, let's simplify first multiplication, 10 times negative 8, that is negative 80, plus 21 times 4, that is 84, minus 12 minus 8. Now, so we have 2, negative 80 plus 84, that is positive 4, minus 12 minus 8. So p of negative 2 is equal to 16 plus 4, that is 20, minus 12, that is 8, 8 minus 8, that is 0. So p of negative 2 here is equal to 0. That means if you're going to divide this number, this polynomial by this polynomial, the remainder is equal to 0. Same as here. You have the same given here, so the remainder is 0. Again, this is the remainder theorem way. Okay, how about number 2? Let's try to identify the remainder using remainder theorem. Okay, so what is the value of a here? So a plus 3 equals 0. Transpose positive 3, that is negative 3. So your P of A is equal to A cubed plus 3A squared plus 2A plus 8. So substitute the value of A here by -3 that comes from your D of A or the divisor. So P of -3 equals -3 enclosed 3 per cube plus 3 times -3 times 2 to the power 2 plus 2 times -3 plus 8. Again, we just substitute A by -3. So P of -3 equals, what is -3 times -3 times -3 or -3 cubed? That is -27 plus 3 times -3 times -3, that is positive 9 plus 2 times -3, that is -6 or -6 plus 8. So we have P of -3 is equal to -27 plus 3 times 9, 27. So this is negative, so -6 plus 8. Then simplify, P of -3 is equal to -27 plus 27, that is 0, -6 plus 8, that is positive 2. Therefore, the remainder here is 2. Same as here. The remainder is 2. Let's go to rational root theorem. Supposedly we're going to get the roots of x cubed minus x squared minus 10x minus 8. So how do we get the roots? Let's have a quick review first. When you were in your previous years, like when you were in grade 9, you are going to get the roots or solutions of this quadratic equation. We have x squared plus 5x plus 6 equals 0. So you can do it by factoring. So factors of x squared, we have x and x. Factors of 6, when you add 5. Factors of 6, we have 3 and 2. When you add, that is 5, so plus. So these are what we call factors. X plus 3 and x plus 2 are factors. When you equate this one to 0, x plus 3 equals 0 and x plus 2 equals 0. So x here is -3 and x equals -2. These numbers -3 and -2 are called roots or solutions or zeros. This is the difference between factors and roots. When you say factors, it is like this, x plus 3 and x plus 2. When you say roots, it's like this, -3 and -2. Okay, so our goal for today is we're going to get the roots of this cubic polynomial. So we have here, how do we get the cubic polynomial? Again, a quick review. When you're going to have a quadratic equation, the highest exponent here is 2. That means there are two roots because the highest exponent is 2. Right? So the roots are -3 and -2. How about here? The exponent here, the highest exponent here is 3. So we can say that there are 3 roots. So rational root theorem will help us. How do we solve, or how do we get rational roots or the roots of this given polynomial? All you need to do is to have a constant term and the leading numerical coefficient. What is the constant term here in number 1? We have -8. Okay? -8 is the constant term. What is the leading numerical coefficient? The leading term here is x cubed. When we say leading term, it is the term with the highest exponent. The highest exponent here is 3. So this is now the leading term. What is the leading numerical coefficient? What is the number here? This is 1 or positive 1. So this is positive 1. Now, how do we get the possible roots? So, before that, in identifying the possible roots, let's get first factors of 8. What are factors of 8? So factors of 8 are, when you multiply, it is equal to 8. That is negative 8 rather. So 1 times negative 8. We have also negative 1 times positive 8. Right? Another one is negative 2 times positive 4. 2 times negative 4. These are the numbers. When you multiply, it is equal to negative 8. We call these one as factors. Okay, so the factors are, we'll just write this by this way. Since there are two, there is one, right? Positive and negative. So positive, negative 1. We have 2, positive, negative 2. So we have positive, negative 2. We have also 4, positive, negative 4. We have also 8, positive and negative 8. So these are the factors of negative 8. There are 8 factors. There are 8 numbers here. Positive, negative 1, positive, negative 2, positive, negative 4, positive, negative 8. 8 factors. 8 numbers rather. Okay, how about 1? What are factors of 1? We have only positive and negative 1. How do we get the possible roots? So this is just constant over the leading coefficient. Leading coefficient here. Leading numerical coefficient. We will just divide each of the factors. Positive, negative 1, which is the constant, divided by positive, negative 1. What is 1 divided by 1? That is 1. Positive, negative 1. Automatic. 2 divided by 1. That is 2. Automatic. Positive, negative 2. 4 divided by 1. That is 4. So positive, negative 4. 8 divided by 1. That is positive, negative 8. These are the possible roots. The possible roots of this given polynomial. Again, there are only 3 roots here because the highest exponent is 3. But there are 8 numbers. So 3 of them, out from 8 numbers, the 3 of them are the roots. Okay, so let's try to make use of one of these numbers. Again, how do we know that it is a factor? The remainder should be equal to 0. Okay, so using synthetic division, so 3, 2, 1, 0. So 1, negative 1, negative 10, negative 8. We will only try here the possible roots. Which of the 8 possible roots here are the 3 roots of this given polynomial. So let's try negative 1. So 1 times negative 1, that is negative 1. Negative 2, negative 1 plus negative 1, that's negative 2. Negative 2 times negative 1, that is positive 2. Negative 2 plus 2, that is negative 8. Negative 8 times negative 1, that is positive 8. Negative 8 plus 8, that is 0. So we can say that negative 1 is one of the roots. Negative 1 is one of the roots because the remainder here is 0. We have already 2 more roots left because again there are 3 roots in all because the highest exponent is 3. How do we solve for the other roots? So you can still make use of the originals and numerical coefficient of the polynomial, or you can use this one, right? So if you're going to use this one, so let's try another number. aside from positive, we're done with negative 1, which is already correct. Let's try positive 1. Is it correct? 1 times 1, that is 2. Oh no, 1 times 1, that is 1. Negative 2 times plus 1, that is negative 1. Negative 1 times 1, that is negative 1. That is negative 9. So the remainder is not 0, so positive 1 is not a factor. So let's try another number here. Let's try here again. 1, negative 2, negative 8. Let's make use of this, okay? It's okay that you will make use of this again. So let's try another number. We have, let's say 2. So 1 times 2, that is 2. 2 minus 2, that is 0. 0 times 2, that is 0. Then negative 8. Again, this is not 0, so therefore 2 is not a factor of this polynomial function. Another number we have negative 2. 1 minus 2 minus 8. So we have here negative 2. So 1, bring down 1. 1 times negative 2, that is negative 2. Negative 2 plus negative 2, negative 4. Negative 4 times negative 2, that is positive 8. Negative 8 plus 8, that is 0. So the remainder is 0. So we can say that negative 2 is one of the factors. Now we have already two rational roots. We have negative 1 and negative 2. We have one more left. Okay? We have one more left. How do we get the other factor? We can make use of this one. Instead of trying another one, 8 here, we can make use of this one. So we have here the remainder, the constant, and the degree 1, as you remember. So this is x minus 4 equals 0. So x is equal to transpose negative 4, that is positive 4. So we have now the three roots. So you don't need to try positive and negative 8 because you already found the three roots, which are negative 1, negative 2, and positive 4. You can say that the roots are negative 1, negative 2, and positive 4. Okay, this time I will teach you how to use Descartes' Rule of Signs. Descartes' Rule of Signs will help rational root theorem to identify how many are positive roots and how many are negative roots. Because when we solved this one a while ago, it takes us time to find the three roots, right? Or how to identify how many are positive roots and negative roots in a given polynomial using Descartes' Rule of Signs. So for instance, number 1, we have here x cubed minus x squared minus 10x minus 8. So before applying Descartes' Rule of Signs, the exponents should be in descending order. So 3, 2, 1, 0, and that is already okay. So from positive here, the positive becomes negative. So that's one change. So from negative to negative, it did not change, so there's no change. Negative to negative, there's no change. So there's only one change of the sign, therefore there is only one positive root. And how do we get the negative root? We all know that there are three roots or expected roots here because the highest exponent is 3. So we will just subtract 3 minus 1, that is 2. So we can say that if we are going to solve this one using rational root theorem, we can determine that there is only one positive root and there are two negative roots. Let's try to check. This is the one that we solved a while ago. Let's check if there is one positive root and two negative roots. Let's check. One positive root and two negative roots. Number 2, how many are positive and how many are negative roots. So here, the exponents are already arranged. X squared, the sign is positive. So, positive to positive becomes positive. There's no change of the sign. Positive to positive, there's no change of the sign. So, how many are positive roots? We have 0. And how many are negative? Since there are 2 expected roots here, because the highest exponent is 2, so the negative roots we have 2. Likewise, number 3, let's solve how many are positive and how many are negative. So we have negative 3, that's negative, becomes positive, so count 1. From positive to negative, that's 2, because from positive to negative it changes to 2. From negative to positive, that becomes 3. Again, negative to positive 1, positive to negative 2, it changes. Negative to positive 3. So there are 3 positive roots. And how many are negative roots? We have 5, which is the highest, 3, which is positive, so there are 2 negative roots. You don't need to provide the missing terms here, 4 and 3. Just have to arrange the polynomial in descending order of powers, 5, 2, 1, 0. So it's already arranged. Okay, how about here number 4? So we have positive, negative. So from positive becomes negative, that's 1. So 1 positive root and 2 negative roots. So 3 minus 1 is. Okay, let's try to apply Descartes' Rule of Signs in determining this example. We're going to find the roots of x squared plus 7x plus 2. Okay, expected that there are 2 roots here because the highest exponent here is 2. Right? So, how many are positive roots using Descartes' Rule of Sign? So, is there a change here of sign? From positive to positive, there's no change. From positive to positive, there's no change. Therefore, expected that there is no positive root in this given polynomial. And how many are negative roots? We have 2. Let's try to solve it using rational Root Theorem. Okay, we have the constant here is 10. What are factors of 10? We're going to get the factors of 10 here. We have 1 times 10, negative 1 times negative 10, negative 2 times negative 5, that is positive 10, positive 2 times positive 5, that is positive 10. There is positive and negative 1, so positive negative 1. We have positive negative 2. We have positive negative 5 and positive negative 10. These are the factors of 10. How about factors of the leading coefficient? What is the leading coefficient here? We have 1. Factors of 1, we have positive negative 1. Because 1 times 1, that is 1. Negative 1 times negative 1, that is 1. How do we get the possible roots? We will divide constant by LC. So 1 divided by 1, that is 1. So positive negative 1. 2 divided by 1, that is 2. Positive negative 2. 5 divided by 1, that is positive negative 5. 10 divided by 1, that is 10. So automatic there is positive negative 10. If there is still number here, like if there is 2 here, 2. So we'll just divide again. 1 divided by 2, that is 1/2. 2 divided by 2, that is 1. And so on and so forth. Okay? Now we have already the possible roots here. So out of 8, there are only 2. But we know that those roots are all negative. So you will not try positive 1, positive 2, positive 5, positive 10. 1, 7, 10 using synthetic division. You will try negative 1. So bring down 1 times negative 1, that is negative 1. 7 plus negative 1, that is 6. 6 times negative 1, that is negative 6. The remainder is not 0. Therefore, negative 1 is not a factor. Okay, let's try another number, 1, 7, and 10. We have, let's try negative 2. 1 times negative 2, that's negative 2. 7 plus negative 2, that is positive 5. 5 times negative 2, that is negative 10. 10 plus negative 10, that is 0. So, negative 2 is one of the factors, right? So, we have one more factors left, which is a negative 1, because there are only 2 roots. So how do we do that? We can also use this one. We can also use this one, or we can also use this one, 1, 7, 10. Then try another number, which is negative 5. So 1 times negative 5, that is negative 5. 7 plus negative 5, that is positive 2. 2 times negative 5, that is negative 10. 10 minus 10, that is 0. The roots are negative 2 and negative 5.